Energy is typically defined as something that gives us the capacity to perform work. As individuals, saying that we feel full of energy is probably indicating that we can perform a lot of work. Energy can be classified as one of two types, either potential or kinetic. Potential energy is defined as being energy at rest or energy that is stored. Potential energy may be classified into three groups. 1. That due to position. 2. That due to distortion of an elastic body. And 3. That which produces work through chemical action. Water in an elevated reservoir and an airplane raised off the ground sitting on jacks are examples of the first group. A stretched bungee cord on a Piper tripacer or compressed spring are examples of the second group. And energy in aviation, gasoline, food, and storage batteries are examples of the third group. To calculate the potential energy of an object due to its position, as in height, the following formula is used. A calculation based on this formula will produce an answer that has units of foot-pounds or inch-pounds, which are the same units that apply to work. Work, which is covered later in this chapter, is described as a force being applied over a measured distance, with the force being pounds and the distance being feet or inches. It can be seen that potential energy and work have a lot in common. As mentioned previously, aviation gasoline possesses potential energy because of its chemical nature. Gasoline has the potential to release heat energy based on its British thermal unit content. 1 pound of aviation gas contains 18,900 BTU of heat energy, and each BTU is capable of 778 foot-pounds of work. So, if we multiply 778 by 18,900, we find that 1 pound of aviation gas is capable of 14,704,200 foot-pounds of work. Imagine the potential energy in the completely serviced fuel tanks of an airplane. Kinetic energy is defined as being energy in motion. An airplane rolling down the runway or a rotating flywheel on an engine are both examples of kinetic energy. Kinetic energy has the same units as potential energy, namely foot-pounds or inch-pounds. To calculate the kinetic energy for something in motion, the following formula is used. Kinetic energy equals 1/2 mass times velocity squared. To use the formula, we will show the mass as weight divided by gravity, and the velocity of the object will be in feet per second. This is necessary to end up with units in foot-pounds.